The last part we'll be talking about sum to infinity. So for example, if you're going to add up the consecutive positive integers like 1 plus 2 plus 3 plus 4, if you add up to 10, we call it as 10. If you add up to 100, it is called as 100. But the meaning of s sum to infinity would be you'll continue to add up infinity. And then we have a notation this is called s infinity. So we use the word infinity to represent the sum. And now let me ask you a question. Do you think that there is a result? If you're going to add 4, 5, 6, up to 10, up to 100, up to 1,000, up to million, up to billion, and do you think that there's an answer? I think you probably guess no, because as infinity in this case, you see the answer is getting larger and larger, and then it goes to infinity. Or you may simply say this result is undefined, and then because you don't think that it can be added up. Similarly, if you're going to add like a negative number, decreasing as, so for example, a plus minus 4 plus minus 9 plus like minus 14 and continuously, you don't think that this one finally reach an answer. So you will see that it's also called undefined. So as a result, there should be some situation that s infinity uh, is valid. That means you can find an answer, and then so that you can really work it out by formula or by whatever a way to do so. And then so on top, you will see that generally speaking, as a arithmetic sequence, there won't be a sum to infinity because it's either you are continue to add up a positive number, or you continue to minus, or you can say you add up a negative number. So finally, it goes to like positive infinity or negative infinity at 2s. So anyway, so the result is undefined. And then in this case, now we will shift the focus to GS. Is it possible to have an answer? For example, like this time, S infinity is 1 plus 2 square, not 2 square, 1 plus 2 plus 2 square plus 2 cube plus 2 to the power 4 and so on. Do you think that is an answer? Not really, because if you add up just integers, you don't have an answer. What do you think you find that the numbers are increasing more rapidly? 2, then 4, then 8, then 16, 32, and so on. You don't think that there should be an answer, right? And then so that's why when you see the numbers are getting larger, then you can't have an answer. But what if you have like 1 plus 1 over 2 plus 1 over 2 square plus 1 over 2 to the power of 2, 2 should be cube, 2 cube plus 1 over 2 to the power 4 plus da, 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 da. Do you think that there is an answer? It comes to a very hard question because it's very, very difficult to guess, right? Because the numbers are getting smaller, but yet it's still sum to infinity. Is that up continuously infinity? So that's why for this one, you can search in the internet. There should be like GIF or video explaining about this idea. And I'll just roughly draw a picture to you for demonstration, which is you can use a geometry approach to explain it, like using area, using square. One in this case, I'm imagining it is talking about a square of area 1. So that means it's 1 times 1 over there. Okay, the length is not really a matter. I just want to have a square of area 1. And what do we mean by 1 over 2? And maybe I change to yellow. 1 over 2, that means it's half of the area of the previous one. Then naturally you will guess that, well, this time it goes to a rectangle. All right. Okay. Addition means you put the figures together. Now you have a shape of like staircase, maybe. Okay, coming up next, red. 1 over 2 square. That means half of the previous one, right? And then that means half of it. That means I'm going to add another square in the figure. Okay, so if the process continue, blue 1 over 2 cube is half of the previous one. Okay, rectangle this time. Next green, 1 over 2 to the power 4, half of the previous one. So this is half of the previous one. Next one, okay, maybe I don't change color. I keep on using yellow. Half of the previous one, half of the previous one, half of the previous one. Can you make a guess that what should be the answer there? You will see that the figure is approaching to a certain figure, which is yes, rectangle. And then so in order to guess the sum or the results here, And then so you should be think of what is the area of this big figure or combinations of all the two figures. Yes, because this area is 1, which is the original, and then on the other side, you'll see that this part will be approaching to uh, the area of this one as well. That means there's another one. So if you add up the square rectangles continuously, and finally it reaches the answer of 2. And then this is the very primitive idea of sum to infinity. Now we come to a question, in what cases that we can have sum to infinity? And firstly, we examine in GS there are some occasions which you have no sum to infinity. In some occasions, like the square and rectangle situations, you see that there is sum to infinity. So let's see the formula itself. And then we are just talking about sum to infinity of GS. AS, just forget it. And then so it's only when we have R is between -1 and 1, and then we have the formula, which is S infinity is A over 1 minus R. You see that the formula is very alike to the one in sum of n terms in GS, which is called Sn is A times 1 minus R to the power n over 1 minus R. But this time you will see that the things in the brackets missing. So let's see how I can remember this formula, this new formula precisely by the following idea. First of all, there's a condition you will see here. Okay, in other words, that means is what examples can you list out? Yes, it may be like 0.5, maybe 0.2, maybe minus 0.3, maybe even you can say 0, maybe it's minus 0.7, so and so. But for all these numbers, there is a very tricky way, which is when you refer to some of n terms in GS, there is a term called 1 minus R to the power n. And so let's see, what if 0.5 to the power n, what is it? Oh, then you may ask a question, I don't know the value of n, how can I estimate it? Yes, but you also see that now the n here, it goes to infinity. That means n itself, it goes to very large. So as a result, we are not talking about power n, for example. Now, how about when you have to try to 0.5 to the power 100, what can you get? Or even you raise it to an even larger number, maybe 100,000, and what is it? If you try it out, then you also try out 0.2 to the power 100,000. What is it? Negative number, what will be the result? You will see that when R is so-called small enough, when you have like 0.5, 0.2, minus 0.3, etc., when it is raised to a very large power, then all of them, they are approaching or going to 0. So as a result, a very little trick I will use will be, well, when you have this 1 minus R to the power n, when R is, when R is between -1 and 1, R is between -1 and 1. So like the examples here, then when it's raised up to power n, which n is a very large number, you will see that the whole expression, this one, will be going to 0. That means for 1 minus R to the power n, it goes to approaching to 1 minus 0. That means it's approaching to 1. So as a result, this item, it seems like deleted because it's just a 1 here. So it's A times 1. So it's A on top only for sum to infinity. So let's see whether this little trick maybe can help you to remember this sum to infinity formula. It's very concise and also very easy to operate because you just have an A and also an R in the substitution to find it. So now we go to example 6 for demonstration. So I'm asking you about sum to infinity for geometric sequence. So let's write down sum to infinity here for my convenience to explain or to do a question. The key to sum to infinity will be you need A and R, and then so that's why in part A you have A is a 3. R, do you remember how to find it? Yes, that's good. You use the next term divided by the previous term. It's like 1/3. Similarly, part B would be A is not -32, while R would be 8/-32, which is -1/4. And then so you definitely need A and R in dealing with sum to infinity of GS, or even when you're talking about simply GS, they are the necessary items you need to consider. And then as a result, sum to infinity will be A over 1 minus 1/3. So what's that next? 2/3, that means 9/2, and that is. The other side, more or less the same. You have -32 divided by 1 plus 1/4, because negative goes to positive. And finally, it's -128/5. It's quite easy, right? Next, we go to example 38, and you have to read the question carefully. It's about GS, first of all. And do you remember that the question is about 3 terms? I told you it should be something about equal sign of latter term over previous term, latter term, previous term in order to set an equation. So you bear in mind it 3 times in ASGS, there's always a little trick to solve the problem. So now you see I'm asking you to find the unknown of K. So as a result, the little trick will be common ratio in GS will be the latter one, just write latter term, divided by the previous term. So which is now you have 2k plus 4, second term over previous term, k squared minus 4. You have 8, the third term, divided by the previous term, 2k plus 4. And now you're going to solve it by yourselves. Alright, so let's take a minute to do so. And I'm doing slowly for you, but don't copy it, but you try to work it out by yourselves. Okay, here it is. But can you be smart enough to read the question again? And I find a little problem over there. Yes, when you read the question, please read the question carefully. Also, like about singular and plural. Because you can see that the question is about find the value, no s. So that means now my answers, I have 2, which are 6 and -2. In other words, that means one of them should be invalid, and you need to reject it. So, but I can't see anything here. So, very easy way would be substitute the answer 6 and -2 into the question and see anything weird or which is unlikely to get. For example, if you try 6, I put it in red. So you have 36 minus 4 is 32. 2 times 6 is 12, plus 4 is 16, 8, ... Probably is okay, right? And then you see the numbers are GS, keep on divided by 2, should be okay. While for yellow one, if you put -2, then you have 0, 0, and 8. Well, then this one, that means it is a 1 I should reject for the answer. Because you definitely find that this one is no longer GS. And then it is one way to do so. The other way, okay, will be okay. Yes, is method 1. So do the substitution and see anything wrong about the sequence. Method 2 will be, there's another thing I remind you quite a long time ago, which is when you are considering division, so like this 2, check the denominator carefully to make sure that it won't be 0. For example, k squared minus 4 can't be 0. So that means k squared can't be 4. Or in other words, k can't be 2, and also k can't be -2. So this is the reason why we reject -2 in the answer. Similarly, 2k minus 4 plus 4 can't be 0. 2k can't be mass 4 or k can't be mass 2. So as a result, in the fraction, in the consideration of fraction, you will see that k can't be 2 and k can't be mass 2 altogether. And so this is another way you can examine or to reject one of the unsuitable answer for the value of k. Alright, then come to part B. Part B, you will need to find the sum to infinity. That means you're asking for A and also R at the same time. So now you can rewrite the resulting method once again. When k is 6, the sequence will be 32, 16, 8, and so on. So that's why A is 32, while ratio is 16 over 32, gives you 1 over 2. So then the rest of the answer will be pretty easy. It's 32 over 1 minus half, which gives you 64 finally. So the question itself is not very difficult. The only thing is, so let's review the question. Number 1, can you apply latter term over previous term to get the ratio? And also, when it's a question of 3 terms, this is the way how we can put them together. It's a very commonly asked question you will find in your exercise or in your exam. And the next, when you talk about sum to infinity, so the key will be you need the A and you need the ratio. So once everything is ready, then you can apply the formula. So of course, you can be more alert to talk about when you apply sum to infinity, make sure that this ratio is more enough. Ratio should be between minus 1 and 1, which later on will test you in multiple choice question to see whether you understand this concept properly.